So first of all, you all know about automata or maybe Petri nets or both. You know about their structure, about their behavior, about some analysis techniques. But it's a nice means to model and analyze concurrent systems, but it needs a bit more facilities for tuning models and a need for parameterization. And that is completely the topic of this tutorial. So we'll have a deeper look into this right now. Why do we want to introduce parameters? We can have several copies of a same process or a same component, and so parameters are useful for dimensioning. For example, if you're modeling sensors in a wireless sensor network, you might have the same kind of sensor that is used several times. So you want to do one model and have several copies and maybe analyze your system saying, I want to consider a system where I have 10 sensors or to consider a system where I have 100 sensors. So there is the number of sensors in this case is a parameter. You can have multiple a priori possible actions. So for example, you can model different design choices. Say, I don't know yet whether I could do this action or that one. And so I leave these two possibilities open for the moment. And then later on, I will define which one I'll choose. So in this case, the action will be a parameter. Another possibility is to model several hardware characteristics. For example, you have hardware with different response times, so in electronic components, and you want to model different kinds of such hardware. Then what kind of parameters should we use for these purposes? It is obvious that if you have several copies of the same process and you want to count the number of processes or components, you need some instances numbering. If you have multiple a priori possible actions, you want to enable or disable these actions. And finally, if you want to consider several characteristics such as response times, you want to have time parameters or probabilities as a parameter. So there are many kinds of parameters that you would like to consider. Now, where are we going to introduce these parameters? Well, in general, when we model complex systems, we would use usual modeling languages that are Petri nets or automata, but they are not sufficient. The traditional ones are not sufficient. So numbering is possible with colored Petri net, but in that case, you need to fix the number a priori. So you give a number and then you run the analysis of your colored Petri net, and if you want to change these value, you have to change the value and run again an analysis of verification. So this is fixed a priori. You can't play on analysis with different numberings. There's no specific handling of uncontrollable actions, so you have all your actions that are present in the model, and in general you can't say whether the action is controllable or not. And the timing is included in timed automata or timed Petri nets, but it's also fixed. You can't say my timing will vary from this time to that time, so you need to know it in advance as well. So in our case, we want to have these as parameters. We want to model parts of interest with parameters, to find some constraints on parameters that guarantee some design properties, and find all parameters valuations that guarantee these properties, so that we can tune the values or know for which values we have the properties that we're interested in. At this stage, you have an idea on parametric modeling issues that consider instances, controllable or uncontrollable actions, time or probability constraints, and you know which are the problems that we would like to address using these. So let us start with timing parameters, and that is the next sequence.